Hi. Good morning, everyone. So quickly, I'm at Radisys, CTO Software Cloud Solutions. We're going to talk about communications and digital engagement platform that Radisys made available as a commercially available product earlier this year. Quick introduction. I'm traveling with a couple of my colleagues. Al Blasco, if you raise your hand there. Al runs heads the business unit, vice president of the business unit. I'm CTO in that same organization. And we have Ralph Page representing account executive from our UK London team. So here I'm going to do the topic, as you probably saw from things, advancing cloud communications beyond the basics. So we're going to talk about what are basics, and I may use the word basics in a way that maybe offends some people, but the idea is not to say, well, this is basics and this is easy. Sure, there's lots of innovation and work going on in what we're calling basics. But we're going to talk about what are we focused on, how is our digital engagement platform above and beyond kind of what has been in the industry in terms of basic calling and messaging. I've got to summarize it quickly like that. And literally leveraging AI and machine learning technology when it comes to real-time audio and real-time video. Kind of that's the focus area of AI machine learning from when we talk about digital engagement experiences. So what we call the basics there are, well, we've seen CPaaS, video calling, voice calling, peer-to-P, P2A, A2P, SMS messaging, two-factor authentication, all that kind of stuff that comes with it in a CPaaS, in a typical CPaaS deployment. Then we have some variants called UCaaS, group collaboration, multi-mode, omni-channel, then contact center solutions, again, around interactive voice response, contact center type of solution, right? Kind of put them all together, expose them to APIs, SDKs, developer community goes and uses them, creates enterprise applications, consumer applications, maybe in some cases even in-network applications. The key areas, of course, where the industry has gone over the last 10 plus years, since I guess Twilio days, is the developer community abstracting complexity. That's the main thing. Now a web developer, mobile developer can very easily, does not have to be a SIP telecom expert, does not have to know the underlying complexity of communication systems, streaming protocols, all of that stuff, right? RTP handling and RTCP and all that stuff. They have an API, they can quickly go and write applications, and they're all around communication space, right? In any kind of one of these three areas. Rapid development to deployment, that's obviously the key part of it. Be able to create applications quickly, launch them quickly, and then of course, as you can do them more quickly, you're able to do more innovation. You don't have to spend 6 months building an application just to find out, well, it kind of missed the mark. So rapid development and more innovation. So this is what I'm calling the basics here. So what's beyond the basics then? So what's beyond the basics is around the same themes that make things that are complicated easy to be consumed by the developer community. Things that are complicated that have already been exposed through APIs and SDKs in the communications domain, messaging, calling, P2P, P to application, application to P, and all the things that we talk about in CPaaS and UCaaS and CCaaS area. So what's beyond the basics here? So what we're talking about is digital experiences that are more immersive experiences. And I'll kind of go through a few slides to start to get an idea of what do we really mean by immersive experiences, what do we mean by Industry 4.0 applications that are really leveraging these days complicated things when you're trying to do a computer vision model, for instance, or a machine vision model, and you need to use that model to create your application. How are you going to go and train that model? How are you going to use that model in real time? And when a certain event occurs that you've had a crowd control situation, I'll pick an example. You point a camera feed to this room here, and if it identifies more than 25 people, they say, okay, this is a crowd count limit threshold reached. Now you need to go and notify SMS message or whatever your business logic is getting you to do, but you need to have that AI machine learning algorithm as part of your application to create immersive experiences, whether it's for Industry 4.0, or whether it's for natural language understanding in the speech domain. So there's many different verticals that require combination of these AI ML technologies when they are applicable in the real-time media domain. So by real-time media domain, in real-time audio and in real-time video feeds, how does an application developer very quickly and easily create a computer vision model and use that as part of his a CPaaS-based application? So those are the fundamental building blocks that we're building into what we call our Engage Digital.ai platform. So if you're not familiar with it, I encourage you guys to go look at it. It provides all of what we're calling the basics that are the table stakes features, which are communications, messaging, calling, group calling, all the standard stuff that you would expect to see maybe in a Twilio or Twilio-like offering. But layered on top of that inside this platform is the ability, and again, exposed through APIs and SDKs, a very easy to consume computer vision, speech analytics, video analytics capabilities that a developer can create very quickly. Can I give you an example that one of our developers did was language translation. So, and literally within 2.5 days of working, wrote an application that does real-time AI-based real-time language translation. So somebody speaking German, the other side person speaking Japanese. Now that application can be developed in less than 2 days. Then people who've done computer vision applications that are also kind of in the same time, 2-3 day thing, you can do scene detection and then have events created based on scene detection. So if those building blocks are not available as part of the platform, and if they're not exposed as part of easily consumable APIs and SDKs, then people will not be able to go create these kind of more immersive digital experiences. So that's kind of what our focus is, going beyond basic communication to leverage AI and machine learning technology as it's applicable to real-time audio and real-time video. So here we kind of look at the traditional building blocks. Up there was the programmable communications part. We call these blocks kind of the enablers where underlying complexity has been built. And above that thing is, of course, like anybody else, we expose them through REST APIs and EML markup language, and we provide SDKs and things that are ready-made applications for people with Jumpstart. They will go and write iOS or Android applications, web applications, or literally embedded into an operator's network. And those capabilities become available because these complex tasks have been abstracted via exposure through APIs and SDKs. So very similarly, what we're doing is this part here, the bottom part. Of course, this is only represented. There's a lot more to it. The box will become really big. But this red box here is all the AI, ML, computer vision, speech analytics stuff. Now, we're then is taking the same idea to take these complex blocks, build them as part of the platform, and expose them to the same set of APIs that web developers use or mobile developers use. So somebody can go and create applications. I'll start to give you some idea of what type of applications can be built once these complex blocks that require machine learning and AI modeling to be easily consumable by the end developer that does not have to be an expert. Just like they didn't have to be an expert in SIP, now they don't have to be an expert in data science and machine learning, because those things have been abstracted, complexity has been abstracted, and you've exposed them through APIs and SDKs. So what are the type of areas? I mean, when we look at it, the underlying fundamental building blocks are very common. I mean, if you talk about in education, for instance, or you're talking about emergency response, or smart cities where you're doing crowd control, or you're doing something in health area, a lot of those things are applications require the same kind of similar building blocks from an AI machine learning perspective. In the domain of computer vision, that's what I'm talking about. There's a whole bunch of data science stuff that is outside that domain. We're not talking about that. We're talking about real-time media, real-time audio, and real-time video feeds coming from, whether it's coming from your cell phone, it's coming from a tablet, or it's coming from fixed point cameras, whatever the streaming protocols may be. You direct them to the media server. The application developer says, okay, now apply this inferencing on this media stream and alert me when this or that occurs. And have that ability in a fully programmable, easy to use programmable way. So many different examples, but the underlying building blocks are very similar from a computer vision and speech analytics perspective. So when we talk about programmable communications, so here I'm going to talk about, it's not programmable communication. Programmable communications is already there as part of this platform. We're saying is that how it's more than just programmable communications. How do you make programmable media analytics, programmable computer vision? In this case, a pipeline. So this is a programmable pipeline. So programmable pipeline means that on the very far left-hand side, you have a source of media coming from somewhere. That source of media needs to be ingested based on the streaming protocol. Could be HLS, could be RTP, could be whatever. You need to have the program. The person who's developing the thing should be able to just instantiate that box and say, take the ingest media stream from these sources, one or multiple sources, do a decode on it, then apply scale or transform on it, and then you might run multiple parallel inference engines. So inference engines, if people are not familiar with that, inferencing is that real-time media. You're going to go and decode the thing into YUV format, and then you're going to say, okay, go look for it, do simplest thing would be you could do face recognition, but it goes way beyond. Do object detection, do classification of a type of an object. Is it a car? If it's a car, then look for a license plate number. If it's a license plate number, then decode it. Maybe it's in Japanese, maybe it's in Chinese license plate, or is it numerical with alphanumeric? So you might apply multiple parallel inference engines, but those inference engines are part of this pipeline. And the pipeline is being created through this API. So the application developer simply stitches up this pipeline through API calls. So these little dotted lines, we see dashed lines are there. So in a few lines of code, they can create an entire pipeline, whether through a visual design tool or through using the API. So once the inference engine has detected something, you track an object that maybe that's moving, then you might apply another inference engine after that, because now you've detected a person of interest. Maybe, let's say, you've seen the thing, you've done a crowd control, but there's also a person of interest that was all part of your application. So you might apply a second inference engine, crop and scale. You might do overlay, image overlay on top of what you've detected. You might then at that point, you will do an encode. This is not raw video, YUV video. You'll do an encode, and then you'll stream that, fork that thing to record, because it'll go to a recording server. It might get published in real time so people can view it live. If they get an alert, I get an alert what the situation is happening. And an alert on my mobile app, for instance, or web. I'll go click on it and I'll have a live view. It might conferencing 2 or 3 other people who are in the security services, security surveillance application. They'll immediately get conferenced in, and we'll all be watching the same live situation, as an example, right? So it's up to the application developer. What we're doing is, just like in CPaaS, we're providing the building blocks, what we call enablers in some cases. Those enablers are available and easily consumable, so developers can go and stitch up and create a pipeline and have a programmable pipeline. Once that programmable pipeline can be, the type of applications is up to the imagination of the developers, like anything else. They can go and create whatever application they want to now, if it's easy to stitch this pipeline together. So this pipeline, as we're saying, so we support this type of stuff through a visual drag and drop tool, we call VDT, on an online portal, as well as full API, SDK programmability in creating the pipeline, which is part of the application. So over here, the red box, when a trigger occurred, this is what we call traditional, this is where your SMS maybe went out, right? This is where somebody got called into a conference call because we detected an event, a person of interest was just detected. Or the crowd went over 38 people. We said, if ever goes to over 38 people in this intersection or in this room, we need to have some people on the call to find out what the situation is, have somebody go over there. Application ideas are near infinite, obviously, right? The pipeline can be created, and then all the SMS alerting, outbound calling, all the standard CPaaS stuff is here. But we're saying that standard CPaaS communication stuff is here, but the ability to go and create much more immersive applications that make it easy for developers to use real-time computer vision, real-time speech analytics is something that is too difficult, is too complicated for the average developer to become an expert in that area before they're going to go and create an application of this nature. So these things will get provided complete application solution, APIs, SDKs, I think I could already mention that, and the ability to go stitch up this pipeline. Now, the other kind of aspect which is important to when we talk about computer vision is because 5G and edge and distributed networks. This is not the type of thing that you would always just run in a public cloud infrastructure or maybe at a central data center. Because the video feeds, especially the video feeds, and the inferencing has super low latency requirements and consumes an immense amount of bandwidth. So this entire architecture on computer vision, real-world use cases have to be built in a way that they're distributed. So you will do the media processing and inferencing towards the distributed site on the left-hand side, but a lot of the things that are part of the application are not so hard real-time, and they're not consuming that much more signaling and call control and that type of stuff. They will remain further up in the network because those resources might be scarce. They're smaller footprints and they're scarce, but they're highly distributed. And that's where the inferencing really needs to be done. I mean, if you're taking a video feed from a robot that's running around or what have you, that type of latency response is super critical. So you cannot have all the media sent up to the core of the network before you're going to go frame by frame and apply an inferencing engine on it. So you need to distribute those workloads over there. So this solution provides the ability for the application developer to go and say, or the organization that's deployed it, to be able to say this is part of the network, and those workloads will automatically get instantiated at the site where your camera feed is coming from. So that's why you see the live feeds are coming over there. You could process the media over there, and then just the events are coming up over here, and the events tell the application what next step to take once that event is triggered over a certain scene is detected. So similarly, switching gears, so this is not only about video. There's a lot of AI, ML stuff that we've also included as part of this platform. There is a real-time audio, real-time speech related. And I'm going to give you some examples of keyword and phrase detection. If somebody says, hey, Radisys, in a conference call, or hey, whatever, hey, Google, or okay, Google, or you pick your phrase. If I say that in a conference call, a virtual assistant will immediately join my conference call, and I'll be able to tell the virtual assistant, okay, can you dictate this conference call and email me the action items? You need to have those keywords that are not just in conference call scenarios, but in a peer-to-peer call too, in a network call. I call Al, let's say, on a phone, and I should be able to say, hey, Radisys, that's my virtual assistant. It'll immediately, a third party will automatically get called into a peer-to-peer call, and I will tell him, hey, take whatever action items or do whatever I want you to do in real time, in real speech. So hot word or keyword detection, trainable, domain-specific, natural language. By domain-specific, I mean in the medical community, there's a lot of phrases that are very medical-oriented that wouldn't show up in the regular English vocabulary. Or in the finance community, there's a lot of terms that are very finance-oriented. So you need to have the ability to be able to train the library for natural language understanding, so that domain-specific applications can be created rather than using a more general-purpose speech recognition engine. So those things require AI and machine learning from a speech domain. Multiple languages, I think I already talked about it. In 2 days, write an application that does real live point-to-point, language-to-language translation using a platform, because it's going to go and detect the language, do the conversion, and use text-to-speech to play back to the other side, and you're having a two-party call. The trainable noise reduction, I think, will be done as things like, literally, because of machine learning, I think people did noise reduction in the acoustic domain in the past for many, many, many years, but it only goes so far. Removing white noise or removing maybe car noise in the background, those are acoustic methods. Now, because of machine learning, I can take a bunch of sound clips that are of dogs barking. If I have enough of that data sample, I'll say, okay, this is the reference data here, dogs barking. Now, from now on, the model got trained, and now if ever there's a dog barking in the conference, it will actually remove or suppress that noise so the dog barking noise is not removed. Whether it's keyboard clicking, dogs barking, airplanes flying, what have you. So this is the way to do noise reduction, not in the acoustic sense, but using AI ML technology. If I can train the model to say, this is what you're looking for, it will identify it and then suppress that noise from it. So there's a lot of interesting things, not just only from a video perspective, but also in the audio and speech domain that are leveraging these new advancements in AI and ML in the speech domain as well. Sentiment analysis is another one. So a lot of customers work with us and ask us, well, can you determine sentiment from somebody's speech? Now, how are you going to determine, is somebody happy? Are they shouting, or is their voice loud or soft or whatever? You can go and train those models and then be able to, on the background, say, hey, well, how was this call? Customer contact center. Well, you were talking to a customer. Was the customer happy or not? Now you need to determine that. And if he's not happy, then you park that person over here because there's maybe an irate customer. Now you need to be able to call them. You can make a recording all you want, but if you have millions of recordings, who's going to find out, well, which ones were actually an irate customer or actually really needed a call back? So that automated sentiment analysis, again, is one of those things that come out of leveraging this AI ML technology in the speech domain. By the way, we're similarly doing that in video as well. If we have video, in the video feed, we'll tell whether this is a male or a female, what is the age identification, rough age, is he smiling, is he happy, is he angry, whatever. Sentiment analysis from visuals, similarly sentiment analysis in the speech domain. So in the immersive area, I think what we talked about was computer vision, speech analytics. The third aspect, finally, I want to talk about is that once you have that thing, you need to be able to go and overlay. So that's call it AR, MR, XR in a very general broad sense, right? Because once you've detected a certain scene, you do need to be able to overlay what the actual video feed is showing you. Because somebody gets a package and they don't know how to deal with a router. It's an older person, they'll just point the camera to it, it'll automatically detect this is the type of product, here's a serial number. They will contact you with the customer support person. While you're still pointing the camera, they will tell you what to do with the object. So in this case here, somebody's pointing their camera to the cappuccino machine and they don't know how to use the thing. So you just point the thing into text, this is this cappuccino machine. It's highlighted the second, it's kind of hard to see from this picture here. And now on your phone, you can press the thing and it will speak back to you and say, hey, this is how you use it, whatever. So this is a virtual assistant from product support perspective. Use cases can be many, like as I mentioned, use cases can be near infinite. We're providing the building blocks and easily consumable building blocks so people can go and write these applications very quickly, not have to spend months and months and months and become a AI ML expert to be able to write this. Just like you don't have to be a SIP expert to go and write communications applications. So industrial applications like for maintenance and support, there were actually, for a customer, we did a demo where somebody's fixing a car and they're actually changing a tire, filling the oil, filling in the gas, and there's a camera feed on it. There's like 6 action items that need to be done. If any one of those action items didn't get done, then the manager would get notified, say, hey, your car's not ready because this action didn't get done. Or if all actions got done, completed, the scene detection, computer vision is detecting that. Did somebody change the tire? Did somebody go and open up the hood and add oil to the thing? Whatever. Think of your use case, right? I mean, maybe not the best use case in the world, but think about any kind of use case where you can take. In computer vision, you've detected these scenes, and if all those scenes have been verified by the computer vision algorithm, then that job is done. Notify and carry on to the next thing. But if any one of those things didn't get done, they're just going to get logged and tracked, and follow-ups will need to occur. So this is an example of a maintenance support, industry 4.0 type application in the industry realm. But it traverses the consumer, right? Like I say, here's a consumer, he wants help on his cappuccino machine, or here's a healthcare application where even a simple doctor visit might not just be an audio video. Now, hey, I can show you, okay, well, this is what my bruise looks like, or this is what my foot swelling looks like, or what have any kind of those type of things can be done in the healthcare sector as well. So, immersive education, field workforce expertise, remote healthcare. I think I mentioned hospitality and travel experience, where people are roaming around somewhere and then they go and talk to a virtual assistant. And the virtual assistant will be able to go and overlay in real time based on the feed that they're receiving. And this is an application somebody can go and build, and they can build this application pretty quickly and easily now. So when we talk about programmable applications, we're covering programmable applications from a communications perspective, but also from a computer vision, machine learning, AI perspective. I think about the earlier diagram that I showed you with a bunch of block diagrams, right? A whole bunch of it was around basic communication stuff. There's a whole bunch of enablers now that are in AI ML domain, but to the application developer, he just has a larger library or a larger suite of drag and drop tools that you see on the left-hand side there, like the pipeline I was showing you, or if they want to go and write a more sophisticated, more algorithmic application, they have full access to the API and SDK, whether building a web app or a mobile app. So finally, so EngageDigital.ai, what we started with, CCaaS, UCaaS, contact center service, all of those kind of standard table stakes. We call those table stakes features, right? They must be there. But once they're there, how can you do more advanced, interesting applications that are currently not so easily developable today? If I asked an engineer, not a librarian, if they didn't have this thing, they'd have to go and build and acquire an AI model, let alone how are they going to do a decode of the video frames that are coming in, and every second frame, they're going to go and take the thing and do a modeling on it. It's going to be an enormous effort. Now it's a drag and drop pull, and you pull in the library. So model creation is one thing. So you create the model, you train it, then you deploy it, and then it becomes consumable in a very quick and easy way to develop applications. So that includes speech analytics, video analytics, computer vision, and also this immersive where you're doing the mixed reality overlay on top of the video feeds that you're seeing. So finally, I'll just kind of leave it on there, maybe a couple of questions if there are any. We truly believe in proof is not in the proof is in the apps. And As I mentioned, we launched this platform earlier this year, commercially launched. We've been working for a while. It's not new to us, but we commercially launched it earlier this year. And thanks to Alan and team, we participated in the global TAD hack, and some really, really cool and interesting applications built over a weekend. So it was actually 23 that were done based on the Radisys Engage Digital platform. They were so good we had a tough time picking winners. But nonetheless, yeah, so 6 winners announced. If you go down to engagedigital.ai TAD hack, I think you'll probably see it on TAD hack too.
Yep.
If you're interested in seeing the list of applications that were built over the weekend and actually maybe even try them out, definitely more than welcome.
Excellent. Thank you so much, Adnan.